There are many different types of flooding which fall under three main categories. The first results from overflow. After heavy rain, a river can burst its banks. The water can engulf entire valleys far from the precipitation zone. Other tributaries add to the flow of water, worsening the deluge further downstream. The second type of flooding involves the accumulation of water in lowlands or basins. In normal weather conditions, water is absorbed into the ground and merges with the water table. When the ground is saturated, water builds up in low-lying areas. Runoff then quickly fills the valley and its waterways. The third type is caused by urbanization in flood-prone areas. Excess water passing through drainage systems can accumulate in low-lying zones. This effect is worsened by the coverage of land with buildings and impermeable surfaces such as concrete. Less water can be absorbed into the ground, overloading sewers.
Floodwaters can devastate neighborhoods near the ocean or rivers. But now geologists are using three-dimensional flood mapping to save lives before waters rise. Joseph Jones is a hydrologist with the U.S. Geological Survey. The agency uses terrestrial LiDAR or T-LiDAR to make 3D flood maps. The technology is similar to radar, which stands for radio detection and ranging, but LiDAR stands for light detection and ranging.
It uses infrared pulses instead of radio pulses, and it gives us very, very high accuracy elevation data for input to our numerical models.
Geologists send infrared light pulses from a plane or truck. They measure depth and distance based on how long it takes the light pulses to bounce back to the source. T-LiDAR quickly collects millions of readings. Then geologists can map hurricane damage and can make 3D maps of damaged buildings, dams, and levees. The U.S. Geological Survey uses its data to make flood maps that predict where and when a flood will happen and how high waters will rise. These maps are released 2 days before the flood, so homeowners can get out and rescue teams can pre-position gear.
We're able to use the Internet Map Server to send those maps out over the Internet to the public, to emergency responders, the fire department and such, so that they can prepare for the flood before it arrives.
It's possible to turn this data acquired from Mitsubishi Mobile Mapping into a product with high added value through post-treatment solutions developed by ISM. We are constantly developing new applications that can be used in a variety of different fields. These include the MMS Viewer, which confirms measurement data, the MMS Editor, which edits laser point groups acquired from laser scanners, the MMS Tracer, which overlays photos and point group data to enable the plotting of road features, and the MMS Ortho Generator, which generates ortho images from photographic and point group data. The highly precise 3D data, which is created from the outstanding measurements taken by the mobile mapping system, are used in a variety of different fields.